Roca. I'm a postdoc student in the University of York. I'm working collaborating in the MSPACE project, jointly with my colleague Simon Mair, that he can't be today here, unfortunately, but we're going to present our paper that we're preparing for the project that is part of our project. So I'm gonna just try to, with today's presentation, I want to try to cover all these points. So we'll introduce just a little the context of our study, the research gap that we will try to fill up with this research, and then how we approach the economic environmental impact assessments, and then the data and sources where we gather all the information, and then some brief, the most important part, the results, and then some brief conclusions. So, sorry. So let me start saying that in the context of the United Kingdom, according to some recent studies, it is obvious that there is some impacts of the climate change on the United Kingdom waters that is being affecting the biodiversity and also the all communities and regions that are dependent on this biodiversity. On the other hand, it's always also detected that globally marine related industries were one of the main CO2 emissions, carbon emissions in the world. Just as a fact, in 2016, the amount of the carbon emission release was 4 times greater than in 1950. Also, the European Union study pointed out that the transport-related sector was accounted about 30.5% of the total emissions in the European continent. So it gives an idea how the amount of the importance of the impact of these carbon emissions are affecting the world in this case. So in this case, the conflicts between the environment and the economy are trying to be solved through the arise some potential conflicts between different targets, economics and environmental targets. So one of the tools that is used to approach these conflicts or try to reduce them is through the marine spatial plans, that they are basically like a political process where is looking for the most proper policies that try to address the environmental impacts while are trying to reduce the conflicts between human activities. So with this demonstrated that well-implemented marine spatial plans can increase as the gross value added production employment of industries, mainly in the marine related industries, but also they are taking care of the environmental conditions. So, however, sometimes as I said, the economic and the economic and environmental impacts can be in conflict, can get in conflict. So this is a problem, or this is a criticized part of the marine spatial plans, because sometimes in some cases economic targets have been prioritized before the environmental objectives. So most of the research are in the literature is devoted to the technical side of the marine spatial plans, and also like examples of step-by-step guides how to approach and just to follow just to implement a successful marine spatial plans. Most of the academic, also the conceptual side is and technical aspects are because marine spatial plans are missing of good quality of economic data, for instance, or because of the time that takes the implementation of the marine plans makes difficult researchers to have analyze empirically this kind of project, this type of projects. So we will try to contribute to fill this gap with our research in the empirical side. So in our case, what we try to approach is to try to measure through some multipliers. We will try to measure how potential conflicts between environmental and economic objectives of the marine plans for some important marine sectors can be addressed in order to make better decisions for the policymakers. So just briefly, let me show you how we will see the impacts in economy. So basically, you have to think that an economy can give an economic shock, external shock, through an external shock can be through I don't know. We are measuring the impact. Sorry, let me start saying that we are measuring the impacts on the industries through an increase of their output that can be given from an external shock. This external shock can say, let's say, like due to an investment of the government, or because an increase of the final demand of customers. So that kind of impacts of shocks initially will affect the increase of the production of the production itself, of the industry itself, because the producers will try to meet through the increase in demand, the increase in production, those external demands these external increased demands. So this are called the direct effects of the economic impacts. So the indirect impacts are those that are given in the supply side. That means that because of this industry will increase the production to meet that impact, that increase in demand. They will need also to more intermediate consumption from their suppliers, so they will affect their production also. So they are measured by indirect effects. They are called the indirect effects, sorry. So basically these impacts on the supply chain and on the industries are measured through the multipliers. We are talking in the context of input-output analysis, that basically is an algebra model, a linear model, we'll say, that can try to measure the interdependencies between the industries. And these interdependencies or linkage between the industries are captured by the multipliers. These are the main multipliers used in the literature to measure these impacts on the economy. But for our study, we basically we focus our attention on the gross value added, greenhouse emissions, and employment. For those that are not related with those concepts, gross value added basically is the contribution of the pure contribution of an economic activity to the economy. In that sense, we say that is the difference between the total value of the production less the intermediate of inputs that is needed to produce this output. Greenhouse emissions are the carbon emission release by the industries that are measured by tons of carbon dioxide. And then employment, in this case, we use a measure that is widely used in the literature. This is the full-time employment. That means that a person that works 40 hours a week, it accounts for full-time employment. And also this measure is used to account for those people who are working less than full-time. So just is weighted for the hour work, just try to compute those part-time workers also. So these are the multipliers, and then we used as I said, this model, what is basically used, it uses matrix data that we collect from National Statistics Office. This data is prepared for every 5 years because it's a really detailed data that is taken mainly by surveys. So it takes a lot of time to be gathered and construct the data. So for this case, we need also, besides the National Statistics Office in the United Kingdom, we also collect the data for NGO as you see in the screen, that is called seafish.org. They provide information for the fishing and aquaculture and fishing processing sectors for the UK. And then we have also, we also take employment data for 2 different sources. For England, Wales, and Scotland, we went to the NOMIS website, but was for the Business Registered and Employment Survey. And then for North Ireland, we went to the NISRA, that they prepared their own data on the employment. And then we follow like a procedure to disaggregate the sectors. We use, for the disaggregation, we use intermediate consumption, also gross value added. We use weights to estimate this data. And then greenhouse emissions, we also collected from the National Statistics Office from England, from United Kingdom, sorry. Well, this is part, now I present how we disaggregate sectors. Initially, as I told you, this is in a matrix. The data comes in the shape of a matrix form. So some sectors are put together in the initial data. So we needed to disaggregate this data using some output weights. So I try to differentiate 2 types of approaches that we follow. In the first one, as you can see in this slide, I wanted to use this metaphor. You know, it's like we take like each of the sectors is like a cake. Take a cake as an example. So we share the cake in a given number of pieces. You know, so imagine we had the fishing and I'm going to put it out with this. We had the fishing and the aquaculture in the same sector. They belong to the sector number 3. So using output data, we disaggregate the data through the weights. So we split the sector into sectors, and then we collect data for disaggregating also the fishing in 7 subsectors that you can see on this slide. And we follow the same procedure for the processing sector that works with initially together with the fruit and vegetables, and also the building of ships and boats, and then with the water transport. Okay, so we didn't take the inland. We put aside inland transport sector because it was out of the scope of this sector of this study, because we didn't consider as a part of the marine industries. For the second group of sectors, we follow the similar disaggregation process, but in this case, what we do is like we take a piece of the cake. When I say that, is because just take an example, the sector of the construction, for instance, that they include from sector from 41 to 43, you know. So we were interested to disaggregate the construction of water project that counts for that is the sector 42.91. So we take a share of the main sector and we separate it simply, okay. And we follow the same procedure with the next for the next sectors, as you can see on this slide. Sorry. So basically we have the results, but before going to the results, I want to introduce for those that are not familiarized with this concept. We use this concept later on just to try to identify which sector are classified as a good sectors, just to implement or to address marine policies. The concept is the sweet spot. we adapt this concept for our study. That means mainly this concept says that a good work is that that provides a good number of of jobs that is not associated with which is associated with low carbon emissions. Also had I think it's like a meaningful work that have some social interaction for workers. So we take two out of three of these concepts. So we use like we try to identify those sectors that will provide a high number of jobs, and also we will be related with low carbon emissions in order to identify which sectors are interesting to implement future marine policies. Okay, so just briefly, as you can see, I wanna show you. That's the main picture of the United Kingdom sectors multipliers. In this case, in this slide, what you can see is the 15 top highest gross value added multipliers in the United Kingdom. You can see that the differences are not that high between them, among them. But here, what is interesting to see is that among them, there is one marine-related industry, that is the repair and maintenance of ships and boats, that presents a multiplier of gross value-added multiplier 0.9. That means that for each million that is invested, okay, or increase in that industry, the gross value-added will increase in that industry by 0.9 million. Okay, that's the interpretation of these multipliers. Next, I show you employment multipliers for the United Kingdom. Also, in this case, as you can see on that side, what we see is the number of employees, the full-time employees, that is created by 1 million of output increase, given an investment or an increase in the final demand of these on these sectors. Also, now, what is interesting to highlight is that we have in this case, two fishing subsectors. This is the low activity fishing subsector, and this is the NIFROPS subsector, fishing subsector, that you can see that for each 1 million invested in or increase in that industry's output, they will increase in 27 workers directly and indirectly, okay? And in the case of NIPROM is 22 employers. Finally, for this, I present the gross value, the greenhouse emissions multipliers for the United Kingdom sectors. As we can see here, there is a differentiated three groups. We'll say that in the top, there are the most polluting industries. In this case, is the mining, air transport, and the crop among the UK sectors. But here it's interesting to see that almost on among the top 10 highest most pollutant industries in the United Kingdom, we can find the sea transport, freight, and passenger water transport sectors are among the most polluting sectors in the UK. So what we do in this graph, we plot all the information. We plot the gross value added and greenhouse emissions multipliers all together. What you can see, just we have a big picture of how they are in those dots highlighted in red are the marine sectors that we have analyzed, but we wanted to plot in this graph with the rest of United Kingdom sectors, just in order to see the big pictures. As you can see, the sea transport and the sea transport, freight and passenger transport are the most pollutant ones, and also according to the impacts on gross value added are allocated on the top of the most on this graph among the UK sectors. The rest of the marine sectors are jointly with the rest of the UK sectors. Here we use the same approach. In this case, we plot in the same graph employment. In this case, we plot employment with greenhouse emissions. With that, we get a similar a similar graph, I mean a similar scatter graph, because as you can see, the sea transport is still being the most polluting sectors, but they have less employment impacts from among the marine sectors, and also with among the UK sectors. As you can see, the mining, air transport are on the top pollutants, but they do not affect in the marine sector, in the employment that much. Here is what is interesting for our study. We present now the marine sector's gross value multipliers. As you can see here, the sectors that have higher gross value added multipliers are those that you can see on the top. On the top three sectors, we can see the repair, retail, for instance, and renting renting sectors. They present almost 0.9, and some of them are over the 0.9 gross value added multiplier. That means that for each 1 million that is increasing that or invested in those sectors, they will create directly and indirectly, you know, almost 1 million of pounds in this case. Remember that we are saying that when we say directly is in the sector itself and in the supply chain. So marine sectors, this is the employment multipliers. You can see these employment multipliers, the sectors that are more that will have more effects on the employment will be the low activity need for fishing subsectors, but also the building of pleasure sport boats. You see that for each million that is increased or decreased, you can interpret it in both ways. They will, if you increase the investment, will increase in 20 the low activity sector subsector in 27 employees, or NIFROS in 22, for instance, or building in 19 employees. But if we go to the bottom, it's interesting to see here that the sea transport sector, they have barely impacts on the employment. For each million that is invested in this sector, that's barely reach 4 employees in each of the cases. So this is the multipliers of greenhouse emissions. There is a huge difference between here. We see clearly that there are 3 different groups. These three different groups on the top is the sea transport sectors that we can see that they have the most greenhouse or carbon emission impacts for each million that is increased in their production. So it's interesting to see that, because later in the next graph, you will see how we will interpret it. But also it's interesting to see these groups of sectors that means that they are the least pollutant sectors that will cause less greenhouse emissions impacts for each million increase in their production. So now what we can see, we do the same, we plot as we did in the previous graph in the UK sectors. What we see here, we plotted in the marine sectors, gross value added and greenhouse emissions multipliers. What we see here for those, the first thing that we can identify here is that we have 3 different clusters. In those 3 different clusters, what is interesting to see, if we see that the upper cluster, we can see that these sectors are the ones that have highest greenhouse emissions with the lowest, in this case, gross value impacts. That means that the reductions in reduction to try to reduce greenhouse emissions in these sectors, we will not cause really high impacts on the gross value added on these sectors. That is important, you know, because if we want to approach or to address some greenhouse policies, we will not try to get in conflict between the stakeholders of these sectors, because we can at least we can say that their industry gross value added will be not that much affected. So that's the point that I introduced the sweet spot of work, in this case sweet spot of sectors, that within those sectors we identify which sector are the proper ones or more convenient to address the policies, because you can see in the second cluster, we can see that most of the sectors that are within this cluster, they have similar reductions in gross value added. But however, the main difference between those sectors and this sector that is processing of fish related products, we can see that they have high impacts on gross value added. So in this case, processing sector will be the least convenient to address policies. So this is why we highlight in circles of red circles. In the case of the bottom cluster, what we can see, we circle of all of them in red, because as you can see in this graph, they will barely reduce greenhouse emissions, but the impacts on gross value added will be really high. So that's the point of these sectors. The policymakers should be aware of that, because all the policies that can be addressed to them can be highly negative affecting their gross value added. In the next section, we see. In the next graph, we do the same, but in this case, we plot employment and greenhouse emissions. In this case, we plotted both multipliers. And once again, we see three different clusters. In this case, the sea-related transport are also in the high, in the upper cluster, because they are the most pollutant sectors. In this case. And in the middle cluster, we see different distribution of the sectors, but they are similar. They gather similar characteristics, because have similarly potential reductions on gross value added. However, they have different impacts on employment. Remember that we are talking about investment. If we increase the investment of this sector, we increase the impacts on gross value added also, and we increase in the employment. But if we try to reduce the greenhouse emissions, in this case, we will also reduce the employment. That is how it is measured with these models. So this is within those sectors. Again, we identify different, applying the sweet spot concept, we identify that the sea transport related sector are convenient sectors to address greenhouse emissions according to their impacts on employment, because they do not affect that much in employment for each million, in this case, invested in these sectors. But in the middle cluster, what is interesting to see now is the aquaculture and the demersal and seiner sector, the ones that are the most interesting ones to invest or to address policies to reduce greenhouse emissions, because they will not affect that much also neither in the employment. In this case, what is in the case of the middle cluster, the NIFROPs or low activity sectors are the least convenient to address the sectors, because as you can see, we will achieve similar greenhouse emission reductions like aquaculture or demersal seiners, but they will impact in a larger extent on employment. On the bottom, most of all sectors on the bottom cluster, they will not offer really chance to reduce greenhouse emissions. However, among them, there are the two sectors that are the least interesting just to allocate the greenhouse reduction policies, because they will affect the employment in a larger extent than the rest of them. We see that I wanted to highlight this sector because this sector, the retail related sector, also appears in the previous graph when we plotted the gross value added and greenhouse emissions, because the retail also appears there on the bottom, being the only one that affects the gross value added and greenhouse emissions in a really high rate when we try to address greenhouse emissions. Well, there's finally, I want to present some conclusions. This conclusion mainly says that okay, we have, as you saw in the graph, we saw these 3 different clusters that we think that they need different approaches, policy approaches for each of them. So for the first cluster, as you remember, was the marine transport sector. That transport sector offers a really wide range of possibilities to greenhouse reduction policies, because they will not affect employment and gross value added in a large, they will have no really high impacts on gross value added unemployment than it has in the rest of the sectors show in the rest of clusters. So the second clusters, we have these different cases, as you can see, as you saw in the presentation, in the results, but we see that we have similar, they present similar potentialities to cut off greenhouse emissions. However, the aquaculture and demersal trawlers and seiner sectors are the most convenient to reduce house emissions, because in this case, they have no really high employment impacts. This is interesting for policymakers because, as I said, we are trying to look for the most suitable candidates, to address policies in order not to arise conflicts among the stakeholders or employers or sector representatives. So we think that aquaculture and demersal are proper sectors. We saw that the NIFROPs are low activities. They have a really high employment impact in this case. So the policymakers should be aware of that, taking this fact into account. When also we have a processing and preserving of sectors that, in any case, we will recommend this sector as the least convenient, because as you saw, they had the really high gross value added implications, given the similar reductions in carbon emissions or greenhouse emissions. Finally, we have the third cluster. In this cluster, we saw that sector related with marine sector related with renting, retail, repair, and shipbuilding. They were really, they are not really candidates for addressing greenhouse emissions, because mainly they have a really high impacts on employment and gross value added of these industries. And especially we wanted to mention or pointed out that we have the retail of marine related products, the retail sector. We have to take care of that, because we have to be aware of that, because they have a really any of greenhouse policy that try to mitigate carbon emissions in this sector, we will have a really high impact on gross value added in this sector and also in its employment because of that. So this is the end of my presentation. I'm sorry if I escaped some concepts, but any question that if you have, just let me know, please, and I will try to answer your doubts. Thank you. Okay, I found.
Fantastic. Thank you so much, Alberto. That was really interesting, and I'm sure it's going to be really useful to the SMMR net community, especially as it links so much to policy. Oh, and your video's up. There we go.
Sorry, I found it now. Sorry.
No problem. No problem. So we have had a question drop in, so I'll ask this to you, and then if anyone else has any questions, please put them in the chat. We have time for a few before we end today. So this question and comment said, thanks for a great presentation, Alberto. I think this serves very well for balancing social versus economic needs. However, have you thought of how marine natural capital could also be included in future assessments?
Okay, well, actually, we are still working. This is like we want to, actually, we went to this one. This is the first draft, actually. We want to approach it this is like a main picture. It's a general idea, just to have an idea how will be approach the marine policies, actually. because we know that it's a marine policy. In this case, we will need to be focused on in a region, so we will try to focus this. Then in the next extension of the research, we try to approach each marine policy applying to this region characteristics, I will say. So in this case, we will try to include the capital, but we are focusing basically on employment and economic impacts. So we will also on the natural capital, but we just in carbon emissions. We have no capital at all. I mean, we can actually, we are expecting the outcomes from other groups, research groups, that they will provide us the variations of the fish abundance in this case due to the climate change. Thus, we will not introduce, we exogenously introduce the natural capital in our model, but this data will be given by the previous research group. I think as number 2 will introduce, they will forecast the variation of the fishing, the fish biomass. So we will introduce exogenously in our model. So that's why I repeat it many times. When I say increase in demand or investment, we will also due to in the production, we will interpret it like an increase or decrease in for instance, in the production of fish biomass. So we introduce exogenously the fish biomass in our model. So we, for instance, as you saw, if we increase one ton or 1 million of fish, we will reduce or we will increase according to the multipliers. This is the way how we will introduce the natural capital in our model. Okay, this is the point.
Great, thanks so much. Just give a couple of minutes or seconds for anyone else to get their questions in if they want to ask. Now I'll ask a question. I was wondering, is there any bit when you were making getting the data for the model, anywhere that particular sectors that you struggled to get the data that you needed? More of a pitch call in that, is there anything that different industries could do to help share that? Because it seems like a really useful tool, and the most up-to-date data seems to will be the best way.
Well, that kind of models that they demand a really high detailed data. So what I will start doing is, first of all, trying to identify as much as marine related industries as I could. I mean, and then as I think most of we do, we try to gather the data, and according to the availability of data, we try to construct the model. So in my case, I try to disaggregate as much sector as I could, sorry. And in this case, most of data came from the business registered database that was fully available till 2014. So the most updated data was that one. That was really good one. I don't know why they stopping doing that. I don't know why he didn't stop doing that. But and then we use that data, and we use the weights of this database, and we updated this data for 2018. This is the base year for our. But yeah, and I had to roll out some sectors because we have not, for instance, because we had not the employment data for them or some aspects like that. But at least we got, I think it's around 15, 16 sectors. That is good enough.
Yeah.
Okay.
Great. Cool. We've had one more question drop in.
Yeah.
For aquaculture, I was surprised that in terms of greenhouse gases, it was compared with dredging and other high impact fishing activities. When considering the very low carbon footprint of shellfish aquaculture, is there a risk of missing opportunities to grow this kind of sustainable food production? I imagine it's hard to disaggregate aquaculture, that's quite difficult to say those two words together, into further finfish versus shellfish.
Oh, thank you for the question. It's an interesting question. Actually, yeah, I forgot to say, one of the sectors that we wanted to disaggregate was the aquaculture sector. But if you know, the aquaculture sector in United Kingdom mainly is focused in Scotland. Most of the production comes from Scotland. I think it's, maybe I'm wrong, but was around 95% of the production comes from Scotland, and mainly is the salmon production. We have a small share in the other for the rest of would say products, or how would say the rest of productions would say. But yeah, we had not that data anyway. As the data is negligible, maybe the model is going to capture, but will the result will be not really very good to interpret, because they will have many zeros, and at the end of the day, not the result will not contribute in a really good way. But most important, I will able to do it if I had the data for that, but this is not, there is no data for that, I mean, unfortunately.
Okay, great to know. If there's no other questions, then I think we'll end it there for today. But you have Alberto's email, and I'm assuming it's all good if you drop him an email if you think of something after the webinar.